Hi everyone, welcome to lesson 9-2 video 1, and we're going to start talking about what sequences are. So to begin with, we're going to answer this question, what is a sequence? And we're just going to keep it simple and say that a sequence is a list of terms that follow a pattern. So let's look at these examples right here. So January, February, March, what comes after that? We're just going to say that it would be April. And then here it looks like we've got a sequence of numbers, 4, 7, 10, 13. So what do I have to add to 4 to get 7? Or it looks like there's a pattern here. I'm adding something to get 7, and then to get 10, and then to get 13. It looks like I'm adding 3. So the next number is going to be 16, because 13 plus 3 is 16. Now on this pattern, or this sequence of numbers here, looks like from 3 to 6, I could have added 3, but I could have also multiplied 3 by 2. So let's see how I get from 6 to the next number. So it looks like 6, the difference between 6 and 12 is 6, and the gap keeps getting bigger. So like this is 3, this is 6, this is 12, so it looks like I'm doubling each time. So if I multiply the previous term by 2, so 24 times 2 will be 48. So you have to find the common pattern and then just apply that to get the next number. So here it looks like we're going back and forth between 1 and negative 1. So 1 times a negative 1 gives you negative 1. Negative 1 times a negative 1 gives you positive 1. And then it goes back and forth. So the next number would be a positive 1. Alright, so let's go look at this little chart here to understand what notation is. So in right here, and this is just trying to relate sequence notation to a type of notation that we've seen in the past called function notation, or like whenever we're looking at equations. So n is essentially going to be the same as what we've called x in the past, and a sub n will be what we've called y or f of x. And it's the same thing, it's input versus output. So n is actually going to be called the index. Okay, so this is the index. And then this here is pronounced a sub n, because n is in the subscript. Alright, so the first term we would call a sub 1. The fifth term we would call a sub 5. The 74th term we would call a sub 74. The nth term, or the current term, would be a sub n, and the previous term would be a sub n minus 1. And that's what this means here. A sub n minus 1 means look at the previous term. 2 terms ago would be a sub n minus 2. One more thing, you might see a notation, instead of using a, it might say s sub n, and that's fine too. It means the same thing in the same way that we would call f of x also g of x. So these are all related or are similar to each other. Okay, so sometimes you're going to need 2 ways of writing the equations. So the recursive definition, it's going to use the previous term. So this uses the previous term to find the next term. And you always have to have the previous term. Okay, you always have to have that previous term. Okay, so the explicit or closed definition we're going to plug in the term number to find the term. So if it's a sub 1 or a sub 2 or a sub 3, you're going to plug in 1, 2, or 3 for n and then calculate to find your term. So plug in the term to find the term. And then you do not, I'm just looking on my notes here, you do not have to have the previous term. Oh, sorry, my handwriting's getting pretty sloppy here. Do not have to have the previous term. All right, so let's look at some examples here. So the first term of the sequence is 5. To find the new term, take the old term and add 2. So the first term is 5. So we're adding 2 each time, so the next term would be 7, and then 9, and then 11. And you could keep going with this to eventually find a sub 7. Okay, so 11, what would be, so this is a sub 1, this is a sub 2, this is a sub 3, a sub 4. So a sub 5 is going to be equal to 11 plus 2. So a sub 5 is going to be 13. A sub 6 is going to be equal to 13 plus 2, which is 15. And then a sub 7 is going to be equal to 15 plus 2, which is 17. So we just found a sub 7. Notice we had to have the previous term to be able to find the next term. Okay, now, similarly on this, well, not similarly, but looking at an explicit formula, we've got to set it up first, and then we're going to see how to find the 7th term. So to find the nth term, multiply the index by 2. So remember the index is n, so 2n, and then we're going to add 3 to it. Okay? So what that's saying is that a sub n is equal to, so the current term, so this is my current term is equal to whatever that value for n is times 2 plus 3. So if I wanted to find a sub 7, I would plug in a 7 for n. So 2 times 7 is 14, plus 3 is 17. Okay. All right, good deal. All right, so that is all for video 1, and I will see you in the next video.